not or something.
Okay. So Paul, you were able to add your YouTube and your LinkedIn, yeah? I can see it there, yeah.
Yes.
Yeah,
I
yeah,
wanted to even stream to my Instagram.
yeah. So thanks very much, Shajida. That was a great presentation. Um, I was really familiar with all the responsible AI things as I previously done the AI 900 exam last year. So very good. So Paul, over to you there. Do you want to share your screen?
Okay, I will right now, right away. Good evening, everybody from Nigeria, actually. And at the time may be different over there. So let me just go ahead and share my
Okay,
screen.
we kind of got kind of caught out with the time difference. Are you okay to? I see it there. Yeah,
Yeah, sure, very well, very okay.
yeah, I can see your screen there now, Paul.
Screen. Okay, thank you. So yeah, the topic for today's discussion is building secure and scalable cloud infrastructures. So I'm going to start with building a virtual machine, but then it's more or less we continuing from where we stopped in our previous session. That is what it seemed like. And the last time we talked, we let me try and sign in. We actually tried to explain what Azure Cloud is, and then in the process, we tried to explain the architectures and the hierarchies of Azure resources, and then off from uh, we started off from the management group, which we see as the organization-wide umbrella. After which we then proceeded to the subscription itself, which is used to manage manage our billings. Also, we saw it as a bridge of or a place whereby we can deploy policies and other rules where it will apply to every other things under the subscription. We talked about the resource group, and then as a container that holds together relative resources, and then the resources itself as the actual services that we deploy in Azure. So that day we could not actually continue with deploying any resources at all. And then I think we deploy something which is a resource group only. Yes, this is the resource group that we deployed the other day. And we also talked about the navigation here, and then we ended up to dashboard to see all that we have in the environment. We talked about the global search bar, where we said it should be our friend or our closest friend per se when it comes to Azure without needing to memorize all the resource name of her. You can just come here and search for anything and everything possible. And so, yeah, continuing from there, having discuss resource group as a container that holds resources together, especially those that we share the same windows or that would need to work together just so they can help us to better manage our resources and to clean up when it is necessary. So now we are going to deploy a virtual machine inside our resource group that we created, which is the Azure and AI Show. The first thing to do is to actually acknowledge other possible factors or methods by which we can actually create this virtual machine, right? And the first way is we can actually go to our global uh, search bar, and then hey, we'll just go ahead and search for virtual machines, of which, of course, we have one here, which is the one of the recent services that we've opened, like we explained the other time. And you can go ahead and click, and then you hit on create, right? You hit on create. There are several methods you can use. We have the virtual machine, we have the virtual skill set, we have the presets, all serve different purposes. But for the purpose of this particular session, what we are creating is virtual machine. So if we needed to come through this route, it therefore means that we are going to select a resource group from here within this place, right? And of course, we see subscription that you have paid. We see the we have alternative of selecting other subscription if they are available, and then we can also go ahead and select from the list of resource groups that we have. However, you can as well come to the resource group if you just want it to be deployed directly to the resource group, and then you select your resource group. Now, from here now, what can be achieved is okay, you have the resource group, and it's currently saying we do not have any resource within the resource group. If we've had any, then we would have them populated here. So what we can do from this place is to just go ahead and still hit on create. So what are we actually creating, right? This time around, we are not creating another resource group, unlike when we were in the virtual machine, and then we click on create, it's taking us to go and create a resource group. No, in this case, it's taking us to marketplace. Marketplace, we want to see it as a place, as a normal regular market where we go to purchase item. So this time now, we remember that Azure, of course, is a is a cloud platform that is owned by Microsoft, and is a pay as you go service. Um, that Microsoft render. So you actually pay for what you are using. So we can as well see it as a market where you go to get what you want. So this is a marketplace it has taken us to go and select from the list of services that are being rendered or offered by Azure to select from. Now, the first thing you will see here, popular marketplace products. These are the products that are very popular within Azure that people regularly deploy. This first one you are having here is the virtual machine, and we have various form of virtual machines that you can actually create. In this place now, the first one they are saying Windows Server, the second one they are saying Windows 11. This is a regular Windows machine, and then we have here Ubuntu. Yeah, this one now is a Linux machine. We have SQL, Debian, Linux, Red Hat is still Linux, and all. Then we have the trending now. There are a lot, right? We see the Logic Hub. There are a whole lot that you can. So now, in this case, when we want to create from the marketplace, when you hit on this create from here, you have a list, a whole lot, right, that you can select from. Is it Windows Server, Annual Channel, normal, regular, Windows Server 2025 Data Center, Azure Edition, and all. You tend to select your the kind of virtual machine that you want to deploy from here, the OS type, right? And then you come to Windows 11. Yes, we have a whole lot of them. You see if it's the enterprise, if it's the pro, then you tend to select whichever that you want to go with. Okay, so For this purpose now, we will be creating a Windows server, like the other time when we are trying to explain what Azure Cloud is, we tend to make some examples, such as if you need a server, rather than deploying a physical one, you can host one in the cloud. Right now, I want you to look at this server that we are creating has a physical server, and picture every other elements that are needed for a physical server to work, such as network cables, such as power, you know, cooling, and all of those things that are essential for a server to function properly. So I want you to have those pictures at the back of your mind, because obviously, yes, they will still be working within this environment, only that we cannot get to see them with our physical eyes. So when we hit on create, we want to choose an edition and the type of machine that we want, right? So we have here Windows Server Data Center Core. Now look at this Windows Server 2025 Data Center. This one is talking about the GUI version, whereby you tend to interact with the operating system, right? And then this one is talking about the Azure Edition core. The core you tend to interact with using command or prompts, using command to interact with the machine itself. Then we have 2022. Yeah, we are going to go for this 2022 data center Azure edition. So when you hit on it, it's just going to take some time and go ahead to get us to where we can carry on with the configuration. Now, you see one thing that happened here. Yes, you can as well still go ahead and select another resource group. However, it automatically picked it because that is where we went from, right? And then obviously the resource group belong to this particular subscription. If we should choose another subscription, I'm expecting that that resource group should go, and it will not be among the resource groups that are available for the other subscription. So they are more or less isolated, a more or less a different environment on their own, because each belongs to a separate subscription, right? However, you can use a management group to manage the both subscription together. So going back to where we came from, yes. So yeah, one important thing is the instance detail, which is the virtual machine that we are creating. What is the name you want to give it? Right? VMs have two names: the Azure resource name, unchangeable after creation, and the guest host name, changeable after login. When created in the portal, both use the same name. So we're just going to give it a name and say Azure and AI, then let's just use it as VM, right? Okay, so for resource group name, the underscore is permitted, but in this case now, we say Windows VM names may not contain either a full stop or uh, an underscore, so we can decide to use an hyphen. Yeah. Then for region, remember we were talking about region, we were talking about latency the last time as well. So for region now, you need to pick the closest region to you, just so you can easily access your virtual machine more often, or with a little time, than having it in a very far away region. So in this case, the closest to me, being in Nigeria, is the South Africa, which is of course the African region. So if I need to get access to need to access my result and my virtual machine, it will be much easier and quick for me to access. So for availability now, availability option. So for this, you say choose the Azure region that is right for you and your customer. Not all VM sizes now are available in all regions. We also talked about this the last time. that your the factors that influences your decision based on region can also be SQUs of the resources that you are deploying. They varies based on region. There are some that are available in a particular region that are not, available in the other. So that should also be a very key aspects to consider when considering region. Then availability option. Note something there. There is an asterisk here, which means that it is important that you have a name for your VM and then as well for your region. Then the availability option. Here you see Azure offers a range of options for managing availability and resiliency for your application. Architect your solution to use replicated VMs in availability zones or availability sets to protect your apps and data from data center outage and maintenance events. Now, this is availability zone. Availability option. Which option do I want to pick? Now, the availability zone, as rightly defined here, is the physically separated data centers, across your region. Separate your resources within an Azure region. So if you select an availability zone, you have the option to say, okay, I want my resources to be in zone 1, zone 2, zone 3, just so in case of data or data center outage, maybe there are some issues or there needs to be a kind of repair or something, and there is outage in that particular zone, within the region, your resources can still be accessible using the other, availability zone. Bearing in mind that all of these are cost effective. So in the sense of designing your architecture, you need to also put cost as a key consideration because it is also very, very important. Then you have virtual machine scale set. It distributes your VMs across zones and force domains and scales. So this one now deals with fault domains, right? When a particular VM or sorry zones, how do I put it? A particular um, if there needs to be a maintenance, when there are needs for maintenance in those regions, then your machine, will be distributed evenly across those zones, and then the ones that are up and running, you can always, be able to get across and use them. Then availability set automatically distribute your VMs across multiple force domains and stuff like and so on and so forth. So for this purpose, we will choose the availability zone. Now for the zone option, we have self-selected zone. We can choose up to 3 availability zone, 1 VM per zone, right? That is more like you if you are choosing 3 zones, it's more like you having like 3 VMs in 3 different, in 3 different zones within a region. At the end of the day, they have the same configuration, the same data, they are being replicated and all, just so you can fall back to the one in another zone when there is a fault in a particular zone that your, let's say, a default zone, right? Let's just put it that way. So now for Azure selected zone, this even still in preview, you can let Azure assign the best zone for your needs. Then for the availability zone, you can optionally specify an availability zone in which to deploy your VM. If you choose to do so, your managed disk and public IP, if you have one, will be created in the same availability zone as your virtual machine. That is just for note and just for clarity. You can read through if you are trying this on your own. And out of curiosity, you can as well always go ahead to see or to make researches more as you go on. So here you can choose up to 2 or 3 zones. Again, depending on your region. Sometimes some regions do not, or depending on the resources as well, sometimes you may not have the flexibility to choose up to the 3 regions. Sometimes some zones are not available for peak, right? Then the security type, we have the standard, This will just give you the basic level of security for your virtual machine. We have trusted launch, and then we have the confidential virtual machines. So yeah, we're just going to take these trusted launch virtual machines, and of course, we are choosing the image from the marketplace, right? So we can from here you still have that option of changing your mind just in case, right? But yeah, we are the Windows Server 2022 data center Azure edition, and then generation 2, right? You can see all images taking you back to um, the marketplace. So run with Azure Spot discount. Azure Spot offers unused capacity at discount rate. So we can actually do away with all of this. Now the size, this is another thing to consider, right? I want to choose the size to use. This now has to do with SKUs, right? Now, what do you want to choose? What size of the machine do you want to choose? And this has to do with cost as well, because depending on your SKUs, the SKUs you are choosing will also affect how your pricing will be as you go on, and it will also affect the effectiveness of your virtual machine in terms of processors, right? So for the standard DSO, we have a lot of them. We can decide to say, okay, let's use all the sizes that we have. We have the B series, we have the D series. Okay, yeah, now you see B series V2. They are ideal for workloads that do not need continuous full CPU performance. Then we have a whole lot, right? We have V3, V4 for this series, V5, V6, and the rest, right? But for our own case, we can just go for something a bit smaller, right? Something a bit smaller. For example, let's go with, okay, let's see what B2 has to offer. B series V2. Okay, now the cost for this one are 2. The RAM will give you is 8, and then data disk for the maximum IOPS. This is it. Local storage in gig. We have to go and choose that by ourselves. So this is what is available for you. You can choose either of them. So let's just go with this guy here. The purpose is because of the pricing. However, you may not necessarily need this. You may want to go for something more if you want to use the server for more powerful tools, right? You can choose to take any, but let's just select this. So the standard V2 V core 8 gig RAM, 78.11 dollars per month. That is what it would cost. This hibernation is based on management. You can enable hibernation for the VM. Very importantly, for for Windows VM, you have to give it a username and a password that you will be using, right? Now, this is an authentication method. For Linux machine, you can decide to say, okay, no, you want to use username and password, or you don't want to use the username and password. You want to use the SSH, where you'll be needing the private keys and public keys for signing and all of those, right? But for this case, we'll just say Azure and AI, right? There are some names you can't use, obviously, right? So for password, I'll just look for something to use. I just hope that is correct. Okay, let me do something. Okay, don't forget the password has to be complex, right? So now for a method of accessing this particular VM, how it's connecting to them. This is very, very important because it has to also do with security, right? You can decide to say, no, you don't want to allow any port open. But in this case, you will have to carry out a lot of configuration, maybe going to allow only your only your IP address will give you the IP range, right? How you want to access your VM. Right, but in our case, let's just select this port here 3389 RODP. That is the default method of actually accessing our virtual machine, and it's the most easiest way. Then we go to disk, you go to next disk. In this now, you you see here OSDs, how many gig. This now has to do with storage capacity, how many gig you want to give the virtual machine. You can say 256 gig. Do you want it premium SSD, standard SSD, or HDD? Now, depending on what you have in your production environment, that will determine what to choose from here. If you want your machine, if it's carrying a very heavy load, if you intend to use it for a whole lot of production that will be heavy on it, and you want it to give you the optimal speed, you may want to go for premium SSD. All right, and then management key, platform management key. You also have a customer management key. I do not have any at the moment, so yeah, Azure will be using the Azure management key in this case. They are the one that own the platform, right? So we can go to next networking. This is also very, very important. We talked about networking the other day. So automatically it creates a network for me, all right? And then this is the Azure and AI, VM, VNet. Based on the name, it only just attach VNet to it. And then it creates a subnet for me. Subnet, like we said, it further it's subdividing your network into different segments in the sense of isolating your resources, right? So yeah, it's default. You can decide to say no, you don't want to use all of these. You can go ahead to say create new rather than going with the default they have given you, or you select from the list of virtual network that you already have. So if you want to create new, you have the option of going with this name and then designing your IP address. You can decide to say no, you don't want to use this IP address. You want to use something else, right? You can say 192 dot 168 dot 0.0/16, right? Then you can say no, you don't want to use /16, you want to use /24. But again, bear in mind that when you do this, you will find it difficult to have a lot of subnet just in case there will be need for that in the future. For example, if you need to deploy Azure Bastion, to be able to access the virtual machine even in a more secure way than just your regular RODP, you may have issues with this on the long run. So let's just stick with our 16. The only thing that is different here is the what's it called now? The address, the network address, right? Then we can go for subnet name. This is more like creating our first subnet, right? We can say Azure, okay, Azure and AI. Then we say subnet, right? Let's just put it like this. We say subnet, and the address range. Okay, we can just copy this, and then we go ahead and just use 24 here. Okay, so on this subnet, we have 256 addresses. On this address, we have 65,536 addresses. For this, I must tell you that 5 of these addresses cannot be used because Azure will reserve 2 for themselves, and the first one will be the network ID itself. One will be used for broadcast, and then the other one will be used. Okay. The other one will be used for network gateway. So we can just go ahead and click on OK. Rather than going by the default, it now gives us, what we have designed. For public IP, Azure will give you its own public IP, which is new, and then you have option of selecting the ones that you already have, or you can as well go ahead to create a new one. The difference here is you are not configuring your IP address here. Azure will definitely just give you anyone. Yet the only thing you want to change is if it is static or dynamic. Even from here, we don't have dynamic option directly, right? You can choose internet and all of those, but want to use the routing preference to be your Microsoft network. Okay, so we don't necessarily need this, but you can do all of those things there. Then the NIC network security group. This is a network interface card, right? It works with the public IP, which will enable you to connect to the uh, VM, right? So yeah, you can still go ahead and read, select anyone. Again, the ports, we've seen that in the previous page. Load balancing, we are not using any load balancing options, so we go for none. If you want, you can as well configure all of this. There are other approaches to them, but for the purpose of this session, being basic, we'll just go with what we have. So now, for did I go to review and create? So for management, monitoring, for management, we can we saw something like hibernation before. So in management now, you can decide to configure what we call auto shutdown for the VM, because the number of times that the VM is available determines how Azure will charge you, will cost you, right? So you can decide to say, okay, from 7 p.m., that is usually the default actually. From 7 p.m., you want your machine to be shutting down on its own, right? You have those options. You can enable what we call boot diagnosis for just normal checks and all. Then monitoring, we talked about monitoring is just irregular. There are a whole lot. You can just decide to be, checking them out one after the other. Then we talked about tags the other time. We talk about advanced, right? My time is fast spent, so we are just going to create. I don't even know how I managed to click back before. So from here, you just get to see the detail of what you have selected or your settings so far. So it has validated. We just need to get the validation done, and then we hit on create and wait a few moments to be deployed completely. So you can just review all of your settings, and if you need to make adjustments, you go back to where you need to. So you just hit on create. All right. So as it's coming up, I want you to still observe something. I don't know why it's taking a whole lot of time, but yeah, it will be happening in no moment. Okay, so initializing deployment, and yeah, we have it in our notification already. This is where you get to see what is going on in the background. So yeah, this is it. Now, the other day we were saying that deploying a resource in Azure may be accompanied with other resources to go along together, in the deployment. So in this particular case now, we have Microsoft Network being deployed. We have the public IP being deployed. We have the network security group being deployed, and then we have and the virtual network being deployed. The same time, all of these are already deployed, right? Now, what we are now waiting for is the VM itself to be deployed. Okay. Obviously, it cannot work on its own, so it needs all of these guys to be able to work together. And if you want to see the details of the operation, for example, how long it took for the particular resource to create, you can go on ahead and just click on the operation details, and then you see this took 11 seconds. This is the tracking ID, and all like that. Okay, so deployment is complete. Now that it's complete, you can just go ahead and say go to resource. You also have that in your notification too, right? So you go to resource. This is it. This is everything we've done. Currently, the machine is running. You can restart, you can stop it, you can delete, you can do all sorts of stuff. Now, if you want to now connect to the net and to what is it called now, to the virtual machine, you just need to go ahead and copy the primary NIC, which is the network interface card, the public IP of the machine, and then you go ahead to say RODP. Just hit on your Windows key and then you search for RODP. You hit on it, and then you just paste your public IP, and then you connect. Once you connect, since the machine is on, is I'm expecting it to come up and say, okay, enter your username and your password, but it's taking time. That means it's not going to connect from the look of things. I may not know why. I may just need to try again, right? So when your machine is down, this is how you know when you try to connect, it gives you this error, and then you try to understand why. One thing you can do is just maybe restart or something, right? Then let's try and connect again. Okay, that is one way, right? That is one way you manually enter the VM public IP, and then you try to remote into the VM. So it's not connecting. Another way is you can click on here and say you want to connect. You see connect via bastion. We also have that option. So I just need to quickly connect just so we can end the session. You see we have here you can further manage your the security of your machine, like just in time, sign in, reset password or keys and all of those things there. So what you just need to do is to download the RODP file. This will automatically, okay, please a moment. This will automatically download the RODP file carrying the public IP, carrying the ports. Yeah, complete. So do I want to keep? Okay, let me hit on it again. Do I want to keep? Yes, I want to keep. So let me click on this guy so that it can validate my connection from me. Just so if I was having issue, it can resolve it. So yeah, I can just decide to go and say, okay, open the file itself. So they say now you see that I didn't enter the public key, it automatically picked it. So I will go ahead and say connect. I wouldn't tell why it's not connecting. I wouldn't be able to tell like right now. It's still getting difficult to connect. Let me restart the machine and see. So now restarting the machine is going to shut the machine down, and then it comes up again. Meanwhile, all we just need to do now is to remote into it, which I will try to do before we end. But while waiting for the machine to restart, just in case we have question or question, we can please, bring them up. Let me try and start my other machine and see. Hello, can you hear me?
Yeah, can hear
Uh,
you okay, Paul? Yeah.
yes, we can hear you.
Thank you. Okay, the other machine have restarted successfully. Let me try again to connect. Wow, it's not still connecting. I think, yeah, these are problems that you come across, in production environments. You come across a whole lot that you least expected, obviously, and then that is where you now bring in your troubleshooting skill. There are a lot that you can actually encounter, right? And the best thing, the best you could do is just to try as much as possible to get issues, resolved. So I'm trying that again. Sorry, when that was okay for this one. Let me see. Mm, okay. So if I should check this particular machine, where it's located. This is in West Europe, Zone 1. Okay, what could it be? Now, network settings. But this in particular shouldn't have issue. No. So we say RDP is enabled. So this guy from any range, RDP, priority 300. I don't know. Maybe for the sake of time is fast spent, I may want to look at this at my closest. I don't know if we can just put this on the hold for now. If I'm able to get it started, then I will just have to share with us. Is that okay? Hello, Frank. Is that okay by you?
Yeah, that's okay, Paul. No, you went through everything fairly detailed there, setting up the VM. It was very good.
Okay.
And just there's a message for you there in the private chat. Do you want to have a look at that?
Okay. Okay. Let me quickly look at it. Can I stop sharing now?
Yeah, sure.
All right. Let me quickly check what the message is.
Yeah, I think that was an amazing demonstration there, and I think that's very good,
Mm,
especially part of the networking side, so which is quite very, very important. And these are things most people are not actually aware of. Yeah, thank you very much. That's good.
Thanks, Paul. So, Jan, can you hear me?
Rohan!
How are you?
Yeah, I'm good. Yeah, how are you? Are you able to hear me, Frank?
Yeah, I can hear you.
Yes,
We
we can
kind of
hear
had a
you.
bit of, there was a bit of a mix up in the timing, the way the clocks, so sorry
Saujanya.
about, sorry about that, outside my control. I was on earlier so,
Okay.
you're okay to share your screen?
Yeah,
Yeah,
I'm sharing my screen.
very good. And we're streaming out to 3 LinkedIn accounts and 3 YouTube accounts tonight. Yep, I can see your screen there now.
Okay, thank you.
Yeah, it's visible now. Yeah, cool.
Yeah. I'm Saujanya Curry, currently working as a principal technical engineer in Oracle. And today I want to talk about this topic, explainable generative AI models for anomaly detection in transactional finance data. So, anomaly detection in financial transactions is the critical component in combating fraud, ensuring regulatory compliance, and safeguarding user trust. So, with the exponential growth of digital transactions in the financial sector, the threat has significantly expanded, making anomaly detection a very critical component. And anomalous transactions, often indicative of fraud, money laundering, which require timely and accurate detections mechanisms that can adapt to evolving patterns and behaviors. Traditional rule-based systems and also even some machine learning models fall short in detecting these anomalies in high dimensional and dynamic financial data. So and also in recent years, deep generative models such as variational autoencoders and generative adversarial networks have shown very promising in modeling the normal distribution of transactional data and also identifying outliers based on reconstruction error or latent space deviation. However, despite their accuracy, the lack of transparency and interpretability in these models in regulated financial environments where decisions must be auditable and explainable. And this research aims to bridge the gap by integrating explainable artificial intelligence XAI methodologies into generative AI models, enabling not only robust anomaly detection but also transparency and trust in financial decision systems. While the quick digitization of financial services has greatly increased convenience, it has also led to an increase in unusual and fraudulent activity. Finding anomalies that can point to fraud, money laundering, or data tampering has become crucial given the millions of transactions that take place in real time. Generative AI models such as variational autoencoders have gained popularity for their ability to learn complex distributions and also to identify irregular transactions without needing explicit anomaly labels. Despite their effectiveness, these models are often criticized for being opaque, making it very difficult to understand or justify the decisions they make, which is the major limitation in financial domains where transparency is very essential for regulatory compliance. In order to get around this, more and more academics are looking into combining generative models with explainable AI. And deep learning is being used in conjunction with methods such as SHAP, attention mechanisms, and interpretable latent spaces to improve transparency without sacrificing any performance. So, this combination creates new opportunities for creating reliable, interpretable, and accurate fraud detection systems. While deep generative models like These variational autoencoders have demonstrated strong performance in detecting anomalies in financial transactions. Their inherent black box nature presents a serious challenge in real world deployment. So, financial institutions operate. Also, these financial institutions operates in heavily regulated environments where the rationale behind the automated decisions must be transparent and auditable. Current generative models often lack mechanisms for explaining why a particular transaction was flagged as anomalous, limiting user trust and regulatory acceptance. Moreover, although post hoc explanation tools like SHAP and LIME are commonly used, they are rarely integrated into the model's architecture or training process, leading to inconsistencies between predictions and explanations. There is a critical need for a unified approach that combines the anomaly detection capabilities of generative models with built in interpretability features, enabling both high detection accuracy and transparent decision making. So, the primary objective of this research is to develop an explainable generative AI framework for detecting anomalies in financial transaction data. Specifically, the model aims to integrate a variational autoencoders with attention mechanisms and SHAP based explanation layers to achieve both high anomaly detection accuracy and also interpretability. Also, evaluating the model on a real world financial data set, benchmarking its performance against existing methods, and introducing an interpretability aware training loss that improves explanation fidelity without compromising detection quality. So, for this one, we have proposed the explainable VAE framework that integrates attention mechanisms within the decoder and incorporates SHAP values to enhance interpretability of anomaly decisions. And also, we conducted extensive evaluations on the IEEE CIS fraud data set, demonstrating competitive performance compared to baseline models such as isolation forest, standard VAE, and Ganomaly. And it also provided visual and attribution based explanations for anomalous transaction detection, supporting compliance requirements and analysts understanding. For financial decision systems to be more transparent and trustworthy, explainable AI is essential. In order to help analysts comprehend model predictions, methods such as SHAP offer feature attribution based on Shapley values. So these techniques help human analysts promote regulatory complaints and enhance model interpretability. The necessity for integrated explainable frameworks is highlighted by the fact that the majority of XAI tools are used after the fact and frequently do not align with the internal reasoning of the model. So this is a proposed framework where we use the IEEE CIS fraud data set, which was made publicly accessible with more than 590K rows and 434 characteristics. This data set of anonymized e-commerce transactions is intended to replicate actual fraud detection scenarios. So the data set is mainly divided into two primary files: train transaction CSV and train identity CSV. So model performance and generalizability depend on high quality data pre-processing, particularly in delicate areas like fraud detection. So this proposed framework integrates variational autoencoders with an attention mechanism and SHAP-based explanation to enable both anomaly detection and interpretability. As shown in this picture, pre-processed transaction data is passed through an encoder to generate a latent representation, which is then refined using an attention layer to highlight important patterns. This enriched latent code is used by the decoder to reconstruct the original input, and anomalies are identified based on the reconstruction errors. In parallel, The latent representation is processed by a SHAP-based explanation module that generate feature attributions offering insights into why a transaction was flagged as anomalous. The model also incorporates an interpretability-aware loss to encourage transparency in learning. So, this architecture ensures a balance between accuracy and explainability, which is very critical in financial systems. So, the encoder, the latent space, and the decoder with an attention mechanism are the three main parts of the design, which is based on the modified variational autoencoders. The high dimensional input transaction data is converted into compressed latent space representation by the encoder network, which is also a fully connected neural layer. So, in addition to acting as the information bottleneck, the latent space is very essential for identifying underlying transaction patterns. So, this technique effectively highlights which features contribute more to each reconstruction by learning to give dynamic weights to various latent dimensions. So these are the results. So the experimental design baseline comparisons and performance assessment of the suggested framework were presented here. So to validate the performance, we compared it against three widely used baseline in unsupervised anomaly detection: isolation forest, standard VAE, and Ganomaly. Isolation forest is the tree-based assemble model that isolates anomalies through recursive partitioning. Standard VAE is without attention or SHAP, which is a vanilla VAE to test the impact of interpretability. Ganomaly is the GAN-based anomaly detection method using encoder, decoder, encoder structure. So the performance of all these models was assessed using standard classification metrics derived from the confusion matrix, which is precision, recall, F1 score, and AUC. And explainable explanation fidelity. So precision is the proportion of predicted frauds that were actual frauds. Recall is the proportion of actual frauds that were successfully detected. F1 score is the harmonic mean of precision and recall. AUC measures overall discriminative ability. And explanation fidelity is assessed through SHAP-based visualizations of feature attribution. So, as shown in this slide, the proposed model outperformed all baselines across precision, recall, F1 score, and AUC matrix. The proposed model achieved strong performance across multiple metrics, outperforming baseline models on both detection and interpretability. As shown in this picture, the explainable VAE achieved precision 0.81, recall 0.72, F1 score 0.76, and AUC score 0.91. So this demonstrates model's ability to effectively detect fraudulent transactions while maintaining a low false positive rate. However, a few limitations still exist, like SHAP computation is resource intensive and model performance may degrade in real time streaming due to retraining the models. So, in order to detect the anomalies in financial transactions, this study suggested an explainable generative AI framework based on the variational autoencoder coupled with attention mechanisms and SHAP explanations. The model also met the requirements for accuracy and interpretability in regulated environments by successfully identifying the fraudulent activity and providing feature level transparency using the SHAP values. With an F1 score of 0.76 and AUC of 0.91, the experimental findings on this dataset showed very good performance. Through integrated explanation layers, the suggested approach demonstrated enhanced anomaly identification while preserving interpretability when compared to the baseline models. So, this approach can be improved for computing efficiency and expanded for real-time fraud detection in subsequent work, and also further improving the performance and scalability in financial systems may involve in investigating transformer based or hybrid designs and integrating multimodal data sources.
Thank you very much. That very clear and accurate to the point. Um, the classification part there that you were talking about, was that kind of like, yes, you have fraud, or no, you don't have fraud?
Yes, we have some fraud patterns, yes, definitely. But
Yeah, yeah. That's
yeah,
when you were saying you were using the classification um, model.
correct,
Yeah,
yes.
yeah. Very good. Any questions, anybody? There's nothing in the chat. Paul, Stephen. Oh, we're all good. So we're gone over time this
Yeah,
week.
that was fantastic. Well done.
Thank you.
Yeah, yeah.
Yeah.
Very good.
Mhm.
So it's kind of we're nearly an hour over the time. I'm here nearly 2 hours. So um, thanks everybody for joining the Azure and AI show this week. We'll be back again next week at the same time, and hopefully the times will all be aligned with everybody. So thanks very much.
Thank
Thank
you.
you, guys. Yeah.
Okay.
Thank you. Thank you. Bye.